the number of coatings and materials increase. Extracting and translating that data into smart factory software systems is a critical element. This panel today will discuss some of these challenges, and I'm joined by a very distinguished panel. From extreme right, we have Dave Heller from Heller Industries. To his left, we have MB Allen from KIK Thermal Solutions, I think is the name, or just KIK. And then to my extreme right here, we have Paul Lancaster from BTU.
Thank you.
Okay, so welcome, ladies and gentlemen. And I'll start off straight away with my first question. Oven dynamics are changing quite a lot at the moment, but what technology and market changes warrant investing in new oven technologies right now? Let's start with you, David.
I think what we're seeing in general is a natural evolution of our machines. It's incrementalism very often. The machines become incrementally more reliable, able to give lower consumption of nitrogen and electricity, and somewhat better delta T across the board. The area that we're seeing a step change in technology is in the area of void elimination, where we're starting to see the adoption of vacuum machines.
Right. Yeah, vacuum machines are becoming quite popular. I think there's also another version out there from, I think, Kurt Siessa is doing the frequency control as well.
Yeah.
So there's different versions coming.
Absolutely, and both systems can be used. Each has its relative trade-offs, advantages, disadvantages, but they can be made to work.
Right. Okay. MB, same question.
So I think that's very true with the challenges on the boards now, especially voiding as an issue. People are looking for solutions to be able to get the oven set up quickly, and that's where we come into play, trying to find new means of optimization for some of those challenging technologies. A profile that gets all of those components in spec quickly, changeover, especially here in the US, that's another challenge here from a marketing perspective, because there's much more of an assortment of low volume, high mix. And so doing that oven changeover, obviously any time that's down is costly, so we try to help to get that all optimized for them.
That's true, so time is critical in these changeovers.
Absolutely.
But going back to your point there on voiding again, it seems to be a combination of oven technology, whether it's vacuum or frequency, plus materials, more modified fluxes, and if you get the combination right, you're going to really get rid of these voids. You don't necessarily do it with one technology on its own.
That's true.
Paul?
What we're seeing right now at BTU is all the things that Dave mentioned, but we're also seeing a lot of push for automation, connection to the factory in terms of software. This Industry 4.0 or connected factory is becoming very prevalent in the industry. We've seen a lot of development, a large increase in our R&D dollars being spent on software development, trying to comply with a lot of these requirements. And they're always typically customer driven. We're hoping in the future, because we are the reflow provider, we tend to have to follow what placement does or what the factory wants, but with the IPC committee coalescing around this CFX factory, we're hoping that the industry adopts that on a more uniform basis, because it would be, I think, beneficial for all of us if we weren't always having to develop some unique custom proprietary software interface.
Right, yeah, it's very true. We'll come back on that in a moment, but touching on the Industry 4.0 smart factory, what data can we extract from ovens at the moment, and what will we expect to extract in the future?
Well, right now, you can extract, all your recipe parameters, which are critical, along with in-process temperatures. So a lot of customers want to see, for every board, what the temperature was as it ran through the oven, which would be collected by a KIK system or an OEM option if you have it. You can collect everything from your board temperature, your set points, your belt speed set points, and convection rate. That controls your profile. So the most critical parameters. Aside from that, you can collect, product information, barcode. You can collect information from the equipment, whether it's idle, busy, or working. Collect, power percentages of your heaters, O2 levels if you're running nitrogen. So right now, the ovens, there's a ton of data out there that you can collect. I think the challenge is, what do you do with all that data, and how do you present it in a meaningful way so that the customer can react to it? You start getting more into predictive analytics. So you can start seeing, well, what is my optimal maintenance intervals? So I'm proactive, so I'm not running towards downtime, but I'm actually optimizing my maintenance so that I have the greatest uptime with the equipment.
Right, that makes a lot of sense. I'll skip to you, David, on this same question because there's a lot of data you can pull off. Are people actually using that data at the moment, or is it we just have the capability to draw that data off, and we'll get round to being able to learn how to really harness it in the future?
There's really two questions there. The first is that very often, particularly for automotive customers, they're taking this data defensively in case of product liability issues.
Absolutely.
They need to be able to prove that if there is a problem in the field, an airbag for example, that their assembly process was in spec when that circuit board was made. So they need proof of that, and that's a lot of what we do. But I think to what Paul is saying, the forefront of the future of data collection is predictive analytics using smart sensors that can ultimately let a customer know that they should do some preventative maintenance, or in fact a major component of the machine is about to fail, and they should repair it before it fails.
Right. Well, you could do that with knowing what the designed life is of a pump or a blower or something like that.
In theory, yes, but in practice, we're looking for some telltale signal back from the blower motor or from the heater that says, I'm starting to be different now.
Yes.
It's probably smart to replace me soon.
Yes.
Because again, at the end of the day, it's the gross change in the machine that creates a problem for the user. Refill ovens are very robust. It's not like we have to tweak them all the time. They work really well, except if a blower motor fails.
MB, I mean, what do you see currently draw off of the profiling data, and what do you think we'll be able to do in the future?
So it's very true. The data for analytic purposes is really what we're being asked for right now. So while we can provide what we refer to as a virtual profile for each board, now we can take that data and we can put that into a database. So we're going smart factory as well. So we're taking that data. We've been able to output that. Now we want to be able to gather all of that data, have a nice database. So now you can use that information for analytics, a better search function as well. So it doesn't matter where something was produced in a factory. I have that information at my hands. First for the customer, for the traceability aspect of it, and as well as for the analytics, maintenance purposes, but also for changeover. So by having all of the profiles that I know I need to run at one location, I can also figure out how to balance that at the factory. Where's the best place to run this particular board, on what oven, and then how do I balance that for the least amount of changeover. Here in the US, with the low volume, high mix, we also have a very high mix of lead-free and tin lead still. So that changeover comes into play much more so than it would in Europe, where there's primarily all lead-free.
Right. You mentioned there that you're doing virtual profiling of every board. How do you do that?
Well, we've had our system for many, many years where we are taking information from the basic original profile that was in spec. We correlate that with all of our sensors, going back to sensors, and along with the profile itself, and using all of that information as well as air information and so forth, we make a mathematical model. So when we know a board enters, we can see if there's any difference from when it was run originally, and ultimately predict and document a virtual profile for each board that goes through the tunnel.
So Paul, how can we take this data that we're extracting and start to use it for smart factory applications? How do you see that plugging into the smart factory initiative?
Well, I mean, I think the first step is to get a standard out there, so everybody's operating from the same playbook.
Right.
Right now everybody sort of uses data in a different way. Sometimes too much data is overwhelming, so it really needs to be streamlined and really cut to the point. I think, with this connected factory, you're going to get data from a lot of different equipment, and having to be able to correlate that equipment sets, kind of like with the screen printer and SPI, that's kind of a closed loop already.
Right.
With an oven, it's a little bit more challenging. It's not so discrete, that function. So I think that data, it's going to be up to the equipment providers to educate that customer, but also to the industry to, like I said, coalesce around a standard so that we can educate the customers. Okay, this is where, as David mentioned, if you see amperage increasing on a heater, that data is important to suggest that maybe your heater's going down. Same thing with the three-phase blower. if you see more power or amperage being drawn by that blower, well, then maybe that's predictive of eventual blower failure. So I think educating the customers can be important. It's going to take a lot of work. Everybody's going to do it differently. Tends to be the standard in this industry. And then all these software vendors, they all want to sell their own package.
Yeah.
And that's challenging too, because for us, we're customer driven. And we do want to be we want to sell equipment at the end, so we got to comply with their standards. So hopefully IPC will sort of level the playing field, and that's going to help that challenge be overcome.
David, I mean, is the goal to try and be more and more predictive with the information that you're taking off of the oven? Of course, once you've soldered the components to the board, then it's difficult to be predictive. You're into a rework situation.
Right, and I think this brings up an important point. From our perspective, and I'm sure in general we would agree, we don't want to try to close loop the reflow process off of downstream QA data. We really would rather just have a very robust system that is highly consistent. Frankly, most of these defects don't originate in the reflow oven, so we wouldn't want to use information for that, but we definitely want to try to be predictive in maintenance and failure prediction.
Right. Okay. Now, MB, Kick and some other manufacturers have signed up to this recent Hermes standard that
yes, we have.
is in Europe. Now, Hermes essentially takes packets of data and moves it from machine to machine, but it also controls the belt speed. That's kind of a little bit of a problem for oven manufacturers. I mean, what is your view on it?
Well, as David said, controlling the oven from a third party has been something we've been requested to do for many, many years, but it does come with many difficulties. Upstream or downstream information back has been something I've been requested for even at this show quite a bit. So I'm not sure exactly how that will tie in. Certainly it's our goal to be able to use the tools as a training, as a learning experience. So it may not be an immediate change right now, but at least we can learn from that to determine what changes are required in the profile. Is it a belt speed? Is it a zone set point, or what are those changes? So that's information that we can gather and we can look at as it affects the profile. As far as changing the belt speed on the fly, at this point I don't see how that would be relevant without changing the entire profile, because you can't just change one thing without the other being affected by it. If you change belt speed, certainly your temperatures of your product results will be different.
Yeah, it's certainly going to bring in some issues. Paul, I mean, you mentioned that you're really hopeful for CFX to become standard. Some people are hoping that that Hermes will be able to sit underneath CFX, or you'll be able to use OML or some other standard. Right. So is it better to have an open approach to all of these systems?
I think so, because not all equipment, I mean, there are differences between reflow vendors, pick and place. If you have an open environment, you're going to be able to parse different sets of data that are unique or proprietary to your particular equipment. So an open standard is great. I think the CFX is open. It's a building block approach. There may be data that we may have that it might be different from other vendors that we can put in a CFX standard. And going back to Dave's point, I mean, in this Hermes belt speed adjustment, the oven is really the anchor of the line. It should just be completely solid, shouldn't have any fluctuations in belt speed, temperature, convection rates. Everything should be closed loop and consistent. You can't have other equipment adjusting things on the oven. It's not something that is a discrete process. It's very analog in nature, so when things settle, you don't really want to adjust it. A system like a Kick 24/7 or another set of redundant process TCs will provide that extra level of confidence and traceability that nothing is indeed changing in the oven.
So basically what you're saying, the oven will or should dictate the speed of the line?
Yes.
Do you agree with that, David?
I think that's a reasonable point. Ultimately, the customer has a throughput requirement, they have a profile requirement, and that backs into the belt speed, ultimately. Their customer may want to trim the belt speed moderately for a different profile effect. But I agree with Paul. I think that that's really not the major process variable.
Right.
And that's really where you're optimizing during the profile setup rather than on the fly. You need to establish that before you start production.
Yeah. Okay.
But I think we would all agree if the customer came to us and said, we're going to give you an order for a lot of equipment, all you have to do is vary your belt speed.
Exactly.
We'd figure out.
As long as they don't come back to you with the issues of yield. Okay, what effect is increasing miniaturization having on the reflow process? Let's start with David on that.
We're seeing a moderate requirement for very, very small components. It hasn't required a major change in process control. We've used existing process controls like varying blower speed and such. Often it'll now require an inert atmosphere because the paste is finer, but not a major change. The area where we're seeing some interesting changes, to keep voids below a certain level, people have to keep the temperature below a certain level because certain fluxes interact with certain OSPs, and it's surprisingly critical.
Yeah, that's interesting. Yeah. Okay. What is your view on the miniaturization process?
I agree with David. The voiding problem is certainly a challenge. There's alternatives to that, but a very fast way of trying to avoid the voids is by using a profile. And we're seeing very often it's not only just lower temperatures, but higher temperatures, but not across the board. So we are trying to come up with and have presented many different tools so that a customer could follow the process window that's met from the solder paste spec, but also address the components. Actually to the point where you may have a process window, but you choose to be at the higher end of it or the lower end of it, but you want to optimize on that, yet still be in the process window. So now we're able to provide those tools where the customer could selectively choose a process window for a component as well as the solder paste, and then we optimize to get them a good profile.
Do you create profiles based on the flux that's being used? If you're using a low voiding flux, do you have a specific profiles that you set for these types of products?
That's a great question because we have been asked for that. It's the information that's provided to us from the solder paste manufacturers. Some of them do have more than one profile. Usually the change is a ramp to peak or with a soak, but specific to the flux is not yet. But we are being requested to see that, so we are addressing that in the future, especially as we get into more smart factory tools. That those are other possibilities to consider when you are trying to find a good in-spec profiles, optimizing on in other areas as well.
Right. Okay. Paul, is anybody, any of your customers running 0201 metrics at the moment?
Yeah, there are some. With the miniaturization, I think another concern is you're going to have a lot of product in your oven at any given time. As products get smaller, you can run higher volumes. So being able to have sort of a real-time process control, making sure that everything's in check, because you have a lot of work in process, so you don't want to damage a lot of components coming out. And having a more of a closed loop way of controlling your convection and fine-tuning that convection rate becomes even more critical. Because obviously the convection is sort of the mechanism that you're heating with, and being able to control that with more precision on top of having that verification with the redundant monitoring is essential.
So let's move back to David. What reflow challenges do you see facing you in the future?
From a technology point of view, clearly voids are one of the things that customers ask us about the most. And then it's package and system efficiency and value, because our industry is always under considerable cost pressure. In semicon, the challenges are also interesting for completely new processes that are only being defined now, including tiny components, die on wafer. Very, very interesting. The whole problem.
You see some trickle down in the technologies from that you're employing in the semicon side.
Yes.
Coming down into the SMT world.
The key challenge there is warpage.
Right.
How do we deal with warpage of substrate, warpage of component, warpage of die? And very often in SMT, there's an answer. Everybody knows what it is. In semicon, there's no answer. Nobody knows how to solve this yet. We're all figuring it out now.
It's interesting. I mean, warpage used to be a big problem back in the early days of boards coming into from China, for example, because they didn't bake them long enough to take the moisture out. But that's a thing of the past. But is warpage becoming a bigger problem again because of miniaturization?
I don't get too many questions regarding warpage. Most of what I'm seeing is more the very large cross-section of components on a product to get them all in spec, to make sure that they achieve the appropriate temperatures so that they don't have voiding especially. For me, I see more of a market challenge right now is the collection of data. More and more people are wanting that, as we talked about earlier, and then how to utilize that data efficiently. How do I get that data analytics at my fingertips? I need it to be clear. I need it to be what I want without a lot of the customization. And hopefully that's where the CFX comes in, because if everyone has the ability to output data in a more consistent format, regardless of whether you're a large, a small, or a medium-sized company, I can get started at least. That's what we're looking at. How can I get started with the least amount of cost? We have a starter kit even to get someone the opportunity to, let's try it and see what I need now and what I will need in the future.
Well, one of the biggest bottlenecks to all this smart factory thing is the amount of data you're pulling off. The bottleneck is actually making sense of it, having somebody that can translate it into actionable data, of course. Paul, challenges for the future. What do you see is going to be your...
Well, going back to Dave's point on the warpage, I mean, on the semicon side, there was a show last week, and we introduced a mechanism to help with the die tilt, which has been successful because, and even when we implemented the RoHS standard back in '06, the higher temperatures did cause boards to tend to sag into spike zones. So things like center supports became very popular in reflow ovens. And even now with things getting smaller and thinner, with larger, BGA systems on chips, warpage is important, so you maintain contact throughout the refill process. I think the challenges generally are going to be cost-driven, lower consumption rates, better use of nitrogen. Customers are all being squeezed, and as a result, we're being squeezed too. So,
I think cost is always going to be a factor, but I think there's a lot of technical challenges coming down with the smart factory and with the miniaturization, etc. I think people want to have their problems solved, so that they're willing to pay for that.
While they're challenges, they're also exciting.
Yeah. Well, the other challenge too is getting people to actually pay for software. So, customers just think it should be free because, well, it's not tangible.
Right.
Selling capital equipment is something you can touch and feel. Or software, they think, well, just give it to me on a USB stick, and I'll give you the USB stick back, and it costs nothing.
Yeah.
So that's going to be a challenge too. So it's going to be important to really demonstrate that value to the customer. Otherwise, they just may not want to pay for it. So.
Fascinating subject, ladies and gentlemen, or lady and gentlemen.
Thank you.
I want to thank you all for joining us today. There's no doubt going to continue, and hopefully we'll be able to meet back some other time and take it to the next level.
Right.
Thank you, Trevor.
Thank you,
Dave
Trevor.
Heller from Heller Industries, MB Allen from KIC, and of course Paul Lancaster from BTU. And thank you for joining us, and we look forward to our next panel discussion, which will be tomorrow morning. But for now, this is Trevor Galbraith saying goodbye.